Good day, everyone. So today we will be discussing about the development of MATLAB-based worker productivity assessment using Altair for data preparation. Starting with the project introduction. So in engineering and research, raw data often require time-consuming cleaning and organization before analysis. So to address this, Altair Monarch organizes the data set into structured Excel file, while MATLAB automatically analyze workers' productivity. Together, they provide a faster, more accurate, and more efficient approach to productivity assessment.
Students often face challenges in preparing raw data for analysis due to inconsistent formatting and other data issues. In addition, evaluating worker productivity manually is time-consuming and may affect accuracy. These challenges highlight the need for an automated productivity assessment tool. Therefore, this project aims to answer the following questions. Thus, using Altair Monarch Complete minimizes the time and effort required for data preparation. And to what extent can the statistical results generated by the MATLAB operation application support the assessment of workers' productivity and performance?
The objective of this study is to develop a MATLAB-based decision support application for comparing worker productivity using data prepared through Altair Monarch. The study uses three software tools: Microsoft Excel to record raw data, Altair Monarch to organize and prepare the dataset, and MATLAB to analyze worker productivity by computing key statistical measures and generating graphical results.
For data collection, 5 participants were assigned to sort a standard deck of cards according to suit for 20 minutes under identical working condition. Each participant completed the task using their own pace and work strategy. Throughout the activity, the researchers recorded the cycle time for each completed deck and the total production output. The collected data were initially recorded in Microsoft Excel. Due to continuous nature of activity, the dataset became unstructured, making data organization necessary before further analysis.
To prepare the dataset for analysis, the raw and unorganized data were imported into Altair Monarch for cleaning, and organization. Altair transformed the raw data into a structured Excel dataset, reducing the need for manual organization, minimizing errors, and improving the efficiency and accuracy of the productivity analysis.
After the dataset was organized in Altair Monarch, the Excel file was imported into the MATLAB Productivity Assessment program. The program automatically reads and processes the data, eliminating manual data entry and providing a faster and more accurate productivity assessment.
Once the dataset was organized by Altair Monarch, the clean Excel file was imported into our custom MATLAB productivity assessment program. The program automatically reads and processes the data, completely eliminating manual data entry. Looking at the script's architecture, it first initializes the environmental using clear, CLC, and close all, and reads the Excel file while preserving original variable names. It extracts the unique IDs of the workers to dynamically handle the group size and pre-allocates arrays for the meantime, standard deviation, output, and rate to optimize performance. From there, it enters a for loop that runs through each worker. Inside this loop, it isolates the rows matching the current worker's ID, converts the text-based observed times into numeric data using str2 double, and computes the individual mean and standard deviation while safely omitting any missing NaN values. Finally, it extracts the total 20-minute output and multiplies it by 3 to scale it into an hourly production rate. After the loop finishes processing, the application compiles all these calculated metrics into a clean, centralized table called T, with explicit variable headers, which is then displayed directly in the command window. To make these findings actionable, The program automatically generates a bar chart labeled worker productivity to visually contrast the decks completed per hour across all individuals. Lastly, it leverages the max function to find the absolute highest production rate and deploys an interactive message box pop-up that officially identifies the top performing worker and their exact output rate. Overall, the application successfully automated the productivity assessment process, minimizing errors, eliminating tedious manual work, and providing a fast, accurate, and user-friendly tool for evaluating worker performance.
After the dataset was imported, the MATLAB application automatically computed the mean cycle time, standard deviation, production output, and production rate for each worker. The results were displayed in a table for easy comparison, and a bar graph was generated to visualize each worker's productivity. The program also identified the worker with the highest production rate. Overall, the application successfully automated the productivity assessment process, reducing manual work, minimizing errors, and providing a fast, accurate, and user-friendly tool for evaluating worker performance.
In conclusion, this study successfully integrated Altair Monarch and MATLAB to automate worker productivity assessment. Altair Monarch organized the production data while MATLAB analyzed and compared worker performance, providing a fast, accurate, and user-friendly productivity assessment tool. And that ends our presentation. Thank you.